Okay. Hey guys, it's Mr. Gibson here. I'll show you guys how to find the lengths of the side of a right triangle using trigonometric functions. Okay. Trigonometric functions are these special functions that relate the angle of a right triangle to the sides of a right triangle. Okay. So let me start out here talking about what we're going to call these sides. So we've got our right angle right there. The right angle points at this longest side, which is called the hypotenuse. The angle right here is the angle that we're going to look at, okay? And the angle is next to this side, and that's why we're going to call it adjacent. Adjacent just means next to. And then the angle looks at or points at this side right here that we're going to call the opposite. So we've got three formulas that take the angle and relate it to these sides. So for example, here we have sine takes this angle. This symbol right here is just theta. It's a variable. So it's going to take the value of whatever this angle is right here, theta, and it's going to give us a number, which is a ratio or a fraction that is equal to the opposite over the hypotenuse. The value of the opposite side over the hypotenuse. The value of the hypotenuse. Cosine similar, takes in the angle, but gives you a ratio that's adjacent, the value of the adjacent side over the value of the hypotenuse. Tangent, very similar, takes in the angle, gives you a ratio, but this ratio will be the value of the opposite side over the value of the adjacent side. So let's see some examples of how this is used. Okay, right here, start with this triangle. It's a right triangle. The right angle points at the longest side, which is the hypotenuse. So 5.1 is the hypotenuse. The angle that we have, or what we're given right here, is at 41.1. And the side that we're trying to find is right next to the angle, so it's x. Okay. Because we have adjacent hypotenuse sides, we're going to use cosine. So here's our formula right here. Cosine of the angle equals adjacent over hypotenuse. Again, I'm just going to plug some stuff in. Ignore the red parts right here. I'm going to plug in the angle for cosine. Cosine of 41.1 degrees equals adjacent, which is x, over hypotenuse, which is 5.1. The next thing you do is get x by itself, so that's why I multiplied 5.1 on both sides, because 5.1 over 5.1 will cancel each other out. And I'm left with x equals 5.1 times the cosine of 41 degrees. And what I'm going to do is I'm going to use Desmos, okay? And I'm going to make sure that Desmos is in degrees because our angle here is in degrees. There's another measurement of angles called radians that you'll learn about in pre-calculus or trigonometry, but we're going to use degrees today, okay? And I'm just going to plug this in. I'm going to put 5.1 times, I hit functions, hit here, cosine, and I'm just going to plug in 41.1, oops, not 1.1, but 41.1, and I get 3.84, okay? Again, all cosine does is a function that takes in this angle, gives you a ratio that is adjacent over hypotenuse, and we can use that to solve this triangle. All right, similarly, in this case, we're not going to multiply, we're actually going to divide. Again, we're given a right triangle. The right angle points at this side, which is x. It's also called the hypotenuse. Okay, I'm given this angle right here. The adjacent side has no value with it, but the side that it's pointing at, the opposite side, has the value of 2. So we're going to use sine. So sine of theta equals opposite over hypotenuse. Okay, plug in opposite for 2, plug in the hypotenuse x, and then we're going to switch the x and the sine of 43 degrees. So x is going to equal 2 over sine of 43 degrees. Which equals 2.93. Again, we put that in Desmos. I'm just going to have 2 divided by functions sine of 43, 2.93. Those are the two types of problems you'll see when you're finding the side of a right triangle when you're using the trig functions. Thank you guys for your attention.